All right, so we start the class. Okay, so what we have studied in complex numbers, if we revise the last class, we have studied the basic introduction of complex number. Okay, so we studied the concept of iota. If you remember, iota is the most basic complex number, and based on that, we studied some results on iota, like iota square is -1, iota cube is minus iota, these basic rules. Then we studied the general form of complex number a plus iota b, and I told you that a plus iota b is basically a point in Argand plane, where a and b denote the real part and non-real part of the complex number. So these parts we have already studied. Then one important property, root a into root b is root ab, only when both of them are not negative. Okay, so these were the basic concept that we studied in the previous class. So basically this is the second class of complex numbers, and today we'll first study about the algebra of complex numbers. Algebra of complex numbers. These are the basic rules of complex numbers related to algebra of complex numbers. So algebra means simply addition, multiplication, subtraction, division. Okay. So how we add, subtract, multiply or divide two complex numbers. This we are going to study in this article. Division of two complex numbers. So when we say complex numbers, we are referring to the general form. Okay. So let two complex numbers are let two complex numbers are a plus iota b and c plus iota d. Okay. Complex numbers written in the general form. Let us say their names are z1 and z2. Z1 is one complex number and other one is say z2. Now suppose I want their addition. Okay. So when we add two complex numbers, what we actually do? When we add two complex numbers, what we are supposed to do? We are supposed to add their real parts. Real part of first complex number is a, real part of second complex number is c. So sum of real part and then iota b plus iota d. So ultimately the sum will be a third complex number and it will be a plus c iota b plus d. Okay, simple. You have to add two complex numbers. Just add their real part, write their real part together, and write their imaginary part together. Same is with subtraction. If you want to find z1 minus z2, do the simple maths. Subtract real and imaginary parts. Okay. So this will come out to be a minus c, and iota b minus iota d will become iota b minus d. Then regarding multiplication, follow the distributive rule. Distributive rule means multiply one by one. You have to multiply a plus iota b and c plus iota d. So multiply one by one. You multiply a with both the terms of the second bracket. So this will come out to be ac plus a iota d. Then we'll multiply iota b with the two terms of the second bracket. This will be iota b into c, iota square b into d. Now if you know some result, you can use it here. So, and from these two you can take iota common, and iota square is -1 if you remember what I told you in the last class. This comes out to be ac minus bd plus iota ad plus bc. Okay. So what you observe? We observe that whenever we add, subtract or multiply two complex numbers, we are actually getting a third complex number. Only a single complex number. So sum, difference, product and division of two complex number is another complex number, right? And I'm writing all these results in the general form, that is real part plus iota imaginary part, like that. Finally, if we have to divide two complex numbers, z1 by z2, so a plus iota b upon c plus iota d. But basically, this is not the answer. I have to write the answer in the simplest form. Okay. So, based on the previous class, can anyone tell me what will be the next step that we should do here? What should be the next step? A plus iota b upon c plus iota d. How to actually simplify it?
Rationalize.
Yes,
Rationalize.
good. So we will be rationalizing this term, and we had a discussion about it that we will be changing the sign of the term having iota. So since it is plus iota d, so I will take minus iota d. That will be the rationalizing factor. Okay. Now just do the normal multiplication. AC minus a iota d plus iota b into c minus iota square b into d, and in the denominator use the property a plus b into a minus b, which is a square minus b square. Now this will become AC. See, this part iota square is minus 1, so this will become plus AC plus BD iota. Next part is BC minus AD, and in the denominator it will become C square plus D square. Why? Because iota square is minus 1 and we already have minus here, so it will become plus. Finally, I can write this also as a single complex number when I will split both the terms. All right. So this will be the division of the two complex numbers. Okay. Once again, a third complex number written in the standard form. Okay. So make sure that you know how to add, subtract, multiply, and divide. Okay. Someone is not mute, so please mute yourself. Can some disturbance? Please mute yourself. Now the fifth part is existence of multiplicative inverse. Existence of multiplicative inverse. Let us see what is this. Just a minute. Okay, regarding multiplicative inverse, it is nothing but just the multiplicative inverse.
Sir,
Yes,
could you please scroll up?
yes, sure. Please note down quickly. Is it okay? You want to copy fourth part or what?
So fourth part.
All right, hurry up. Please note down quickly.
So what is
Done,
that you
sir.
have written after multiplicative?
Multiplicative inverse. Multiplicative
Okay.
inverse. I'm telling you what is this. It is nothing. Simply multiplicative inverse is actually the reciprocal. Nothing else. Is also called the reciprocal. So reciprocal, we are familiar with this term reciprocal, right? It is nothing but multiplicative inverse only. So if z is any complex number, if z is any complex number, then 1 by z is its reciprocal or multiplicative inverse. So my purpose was to give you the idea about this term. In the question, they may ask find the multiplicative inverse. Now, if you have no idea that it is another name for reciprocal, then you may be confused or may not be able to attempt the question. Nothing but the reciprocal. So 1 by z is its reciprocal or multiplicative inverse. So sometimes they may ask you this simple question for 1 mark. Find multiplicative inverse. Find multiplicative inverse of, let's say, 3 plus 4 iota. 3 plus 4 iota. Suppose this is the question. So I will write z equals 3 plus 4 iota. I want to find its multiplicative inverse. Therefore 1 by z, which is the answer, that is 1 upon 3 plus 4 iota. But you will not leave the answer here like this. In fact, you should know that you have to simplify it. By simplify we mean rationalization. Okay. Now after rationalization we will get 3 minus 4 iota, and the denominator it will be 9 minus 16 iota square. So this will come out to be 9 plus 16. Why? Because iota square is minus 1. Okay. So finally the value will be 3 by 25 minus 4 by 4 iota by 25. You will always get a single complex number and you need to express it in the general form. Okay. Always remember that. You cannot leave iota and denominator.
Sir, it's just minus, I mean, just 3 upon 25, right?
3 by 25 minus 4 iota by 25. Real part and imaginary part.
Okay, sir.
Alright. Okay, now after this, there is one important term. Let us understand this term first. Modulus. It is more common in use, this term modulus, or they can ask magnitude. Okay. Modulus or magnitude of a complex number. First of all, you should know that what is the geometrical meaning of this thing. Okay. Then you will be able to calculate it very easily. If z is any complex number, if z is any complex number, then its modulus, or magnitude. Note down both the terms. Modulus or magnitude is denoted by mod z. That is okay. Mod z, as the name suggests, modulus or mod z, and is given by, important is this formula, and is given by z equals under root a square plus b square. Mod z equals under root a square plus b square. And what are a and b? Actually, I have taken z as a complex number. You can write if z equals a plus iota b. If z equals a plus iota b is any complex number, then its modulus is denoted by mod z, and its value or formula is given by under root a square plus b square. So what are a and b? A and b are the real part and imaginary part. You find those values from the given complex number and put it here. You will get its modulus. Now the important thing is, what is the meaning of modulus of complex number. If you will understand this thing, you will be able to remember the formula also. See, we have already discussed, please note, we have already discussed that complex number basically represents a point in the eigenplane, right? Complex number represents a point in the eigenplane. We had a discussion about this in the previous class. Okay. Like for example, if z is a plus iota b, let us have a brief recap. Then suppose, then what I told you, that z equals a plus iota b is actually a point in the eigenplane, right? First real part, then imaginary part. And why we have a different name when the working is same? Because of these two different names. We used to call this as real axis and this as imaginary axis, right? And then we used to denote the complex number by
Sir,
this point. Yes.
your screen isn't visible, sir. I tried rejoining.
What about others? Can you see it? What about others?
Yes,
Yes,
sir. Now I can see.
sir.
Now I can see it, sir.
Okay, there may be a lag actually. All right. Let's come back to the topic. See, the complex number is a plus iota b. I was saying that we have already discussed that the complex number, meaning of complex number, what does it represent? It actually represents a point written in the order a comma b. Real part first, then imaginary part. Okay, like 2 comma 3. So 2 comma 3 will be in first quadrant. 2 is the real part, 3 is the imaginary part. What about the complex number? 2 plus 3 iota, like that. But here we are learning about the modulus. So now I am going to write what is the meaning of modulus. Mod z represents mod z represents the distance of mod z represents the distance of complex number z from the origin. This is the geometrical meaning. Complex number z from the origin. So basically, if someone asks you what is the meaning of modulus, you will not say under root a square plus b square. That is the formula. What is the question? What is the meaning of modulus? So mod of some complex number is actually its distance from the origin. Distance of complex number from origin. Why? Because complex number itself is a point. Okay. Complex number itself is a point. So yeah, it will have some distance from origin. So that distance is called modulus z. So if I join this origin to P, then this distance OP is actually called mod z. Okay. We say OP or mod z, it is one and the same thing. And now if someone asks you how to find this value, so those who have studied distance formula in straight line in class 10th, if you have studied the distance formula, you can very easily tell that what is the formula. Okay. So mod z is under root of a minus 0 whole square plus b minus 0 whole square. So that means mod z is under root of a square plus b square. All right, is it clear? Anyone having any doubt in this? It is very easy. See, you should have a complex number in standard form. You should have complex number in standard form, all right? You should know what are the values of a and b. Use the formula mod z is under root a square plus b square and you will be able to find the modulus of the complex number. Is it clear? If anyone having any doubt, you can ask. Otherwise, let's solve some questions on this. Okay, I'm writing the question here then. Let us solve some examples. Easy overall. Just use the formula. Okay, find the modulus of the following complex numbers. Find the modulus of following complex numbers. I'll be writing some parts actually. Okay. I have written. Sorry, this is fifth part. I have written 6 parts here. Okay. I have written 6 parts here. Just tell me what are the modulus of all these. First, you solve all of them. Okay. It might hardly take 4 to 5 minutes or maybe 2 to 3 minutes. First, you write all the answers and then we'll discuss them one by one. Okay.
So there is some disturbance.
Sir,
Yes, have you solved all the parts? Who will tell me the answer of the first part?
2.
Yes, correct. See, simple explanation. Simple explanation. Under root of minus 1 whole square minus root 3 whole square. This will come out to be 2. Alright. Yes. Second part. Who's going to tell me answer
So
of the
one.
second part? Yes, correct. Good. Iota. Iota can be written as 0 plus 1 iota, right? And 0 plus 1 iota, if we want to take its modulus. If we want to write its modulus, it will be under root of 0 square plus 1 square. That is root 1, 1. Alright. Third part. Modulus.
So 5.
Yes, good. 5 is correct because 5 can be written as 5 plus iota 0. See, in the previous class, we had a discussion about this thing. All the real numbers like 5, 7, root 2, whatever type of numbers we have studied, all of them are complex numbers. Why? Because they can be expressed in the form of a plus iota b, where b is 0. That means their imaginary part is 0. So if we want to write it modulus, then it will be under root of 25, that is 5. And you already know from the previous classes that mod 5 is 5 only. We have discussed this also. Yeah. Now what about the fourth one?
0.
0.
0. Yes, correct. Why? Because you need to use the values of iota cube. All right. And iota cube is minus iota, right? So this will become 0, or we can write it as 0 plus iota 0. So its modulus, both the parts are 0. That is real part and imaginary part are 0. So this will come out to be 0 overall, right? So yes, correct. Good. Now last two parts. Fifth one. Fifth is 2 plus 3 iota.
13.
How much?
13.
13.
13. Yes, that.
13.
Yes, good. That is correct. Good. So let us multiply first. We will do the multiplication first. This will come out to be 6 plus 4 iota plus 9 iota plus 6 iota square. This will be 13 iota. 6 iota square is minus 1. This is minus 6. This comes out to be 13 iota. Its modulus. This can be expressed as 0 plus 13 iota. Its modulus is under root of 0 square plus 13 square. That is root of 169. That is 13. Alright. Yes. Last part. Sixth one.
1.
1. Correct. Good. 1 is the answer. So what we should do in this question, we should first rationalize it, express it in the form of a plus iota b, and then find its modulus. All right. So first I will simplify this, and to simplify I will have to rationalize it. So this is the rationalization. Now let us do the multiplication. 3 into 4, 12, then 9 iota plus 16 iota plus 12 iota square. In the denominator, it is the property a minus b into a plus b, that is a square minus b square. So 15 iota. This is 12 into minus 1 because iota square is minus 1. Please note these two values are very important. Iota square and iota cube. They are repeating constantly, right? Then 16 minus 9 to minus 1. So in the numerator only 15 iota will remain. In the denominator it is 15. This comes out to be iota. That is 0 plus 1 iota, right? Its modulus will come out to be under root a square plus b square. Same formula is applied in all the 6 parts. And the answer is 1. Okay. So I hope now you know how to find the modulus of a complex number. You just need to write it in the form of a plus iota b. Pick a and b from there using the formula that mod z is under root a square plus b square. That's it. So an
Sir, we
important
can
term
do like
related.
this.
Yes, please. Can you repeat your question?
Sir, we can do like this. Like how no, the numerator we separately find the modulus and the denominator and then divide it like that. We can do it.
Yeah, you can do it. Actually, these are the properties I have not taught you till now, so that's why I'm not explaining you in that way. When we'll be studying the properties of modulus and conjugate, one more term related to complex number, then we'll be solving such questions based on that properties. But yeah, if you know the property already, then it is correct. But if you have done it by mistake and you are not aware of the property, then please do not use such type of steps now. All right?
Okay, sir.
Excuse me,
All
sir.
right. Yes.
So I got 15 in the denominator.
Sorry, wait a minute. Yes, you are right. Let me check the calculations once again. This is 12, this is 9 iota, then 16, then 12 iota square, then this is 16 minus 9 iota square.
So 25.
So
Yeah,
25 iota
25.
upon 25.
Yeah, right. Sorry, my mistake. See, 9 iota plus 16 iota will also be not 15, it will also be 25 iota, right? And the same thing will be happening in the denominator. Yeah, thanks. But overall, by mistake. So overall, the answer is again same because 25 will be cancelling each other in the numerator and denominator. So ultimately, once again, it will be iota only, but not 15 iota and 15. In fact, 25 iota upon 25. Rest everything is okay. Then another important term related to complex number is conjugate. Actually, we are already discussing about it from rationalization, but let us discuss it separately. Conjugate of complex number. It is very easy. If z equals a plus iota b is any complex number. If z equals a plus iota b is any complex number, then its conjugate, then its conjugate is given by, then its conjugate is given by. Conjugate means conjugate complex number is given by. Okay. Conjugate of a complex number is complex number only, right? So conjugate complex number. This complete term. Okay. Conjugate complex number is given by mod z. This is the symbol. Sorry, z bar. We read it like this, z bar. Okay. This is the pronunciation, z bar. And how we find its value? And its formula is, or its value is, whatever you say, z bar equals a minus iota b. So what is the observation? How to write the conjugate? What is the meaning of conjugate? Meaning I will tell you later on. What is the formula for conjugate? What you do, whatever complex number you have, okay, whatever complex number you have, you change sign of iota to get the conjugate of that complex number. Okay, just remember this thing. So based on this, I have a question for you. Let me see how many of you can give me the correct answer. The question is find conjugate of, wait a minute, 3 minus 2 iota into 2 plus 3 iota by 1 plus 2 iota into 2 minus iota. Tell me what is the conjugate of this complex number. See, conjugate is easy, but here the first thing that you should do here is like simplify this complex number. So let us denote it by z. Okay. Let us simplify this first. Then conjugate will be can be written only in one single line. So the question is basically dependent on simplifying this particular complex number. So if this is z, whatever this expression is, let us simplify numerator. 3 into 2, 3 into 3 iota minus 2 into 2 iota into 2, then minus 6 iota square. In the denominator it is 2 minus iota plus 4 iota minus 2 iota square. So this comes out to be 6 plus 5 iota plus 6 because iota square is minus 1. In the denominator it is 2 plus 3 iota plus 2. Now this comes out to be 12 plus 5 iota by 4 plus 3 iota, right? But still simplification is required. From here to here I have actually only multiplied the terms, all right, and then simplified. Now the problem is still we have iota in the denominator, so we need to rationalize it first. This is not the conjugate, this is like simplification of z only, right? So now I will be able to find z after simplifying this. This will be 48 minus 36 iota plus 20 iota minus 15 iota square. The denominator it will be 16 minus 9 iota square. So 48 minus 16 iota plus 15 iota square is minus 1. Remember this thing. And it is 25 here. So overall z is 63 minus 16 iota by 25. Separated, split both the terms. So you are here. And now in the next step you are going to get z bar. This whole calculation was based on simplifying z only. What about the conjugate? Only in one line. What you will do? You will change the sign of the term containing iota. That's it. Here it was minus with iota. So in z bar it will be plus, and this is your answer. All right. So finding conjugate is easy provided the complex number given is in simple terms. All right. If it itself is a product of three or more terms, then you need to simplify it first, like in this case, and then you will write the conjugate in one line. Okay. So conjugate itself is not difficult. What is important is the simplification of the given complex number. So I am giving you one question here. Let me see what will be your strategy to solve this particular question. Okay, so question is if yeah, before that I would like to discuss one important thing, then we will be solving this. This is regarding equality of two complex numbers. Okay, equality of two complex numbers. Equality of two complex numbers. So without writing much, let me come straight away to the point. If someone says that these two complex numbers are equal, if a plus iota b is equal to c plus iota b, iota d, then how you will compare what, how you will use this thing? Then you will say that a is equal to c and use this word and b equals d. So basically, when you are given that two points are equal, two complex numbers are equal, okay, so that means you will equate their real part and imaginary part. What is the geometrical meaning of this? Two complex numbers being equal. Can anyone tell me what is the geometrical meaning of equality of two complex numbers? Can you explain it geometrically and tell me why A equal to C and B is equal to D? Any one of you? Why we say that A is equal to C and B is equal to D? And can you explain it graphically or geometrically?
Same,
Yes, anyone?
same coordinates on the arcant plane.
Yes, good. So basically, when someone says that A plus iota B is equal to C plus iota D, he or she is indirectly saying that there are 2 points which are at the same position or they are located at the same point. What is A plus iota B? A point in Argand plane. What is C plus iota D? A point in Argand plane. What is the meaning of equal to? They are the same points. Same point means same coordinate. Same coordinate means their real part same, their imaginary part same. That is why A is equal to C and B is equal to D. Okay, just remember this. So now let us take two examples. First question is if, let me see who will give answer to this particular question. If lambda square minus 25 plus 5 iota equals 0 plus minus lambda iota. Okay, suppose this is the equation, then find real value of lambda. Tell me what will be the answer.
So is it 5?
5. No, 5 is not correct.
So minus.
Minus 5 is correct. See why minus 5 will be correct. See, just use the equality of complex number. Using equality of complex numbers. Using equality of complex numbers. What you have on the left hand side, lambda square minus 25, which is the real part. And what is the real part on the right hand side? 0. Similarly, what is the imaginary part on the left hand side? 5. What is the imaginary part on the right hand side? Minus lambda. Lambda square is equal to 25. Lambda comes out to be plus minus 5. And here lambda is minus 5. And means a value which satisfies both of them. So answer is not 5. Answer is not plus minus 5. Answer is only minus 5. Okay. You have to select the common value. If you remember, and usually means intersection or common. So from there also you can think that lambda will be minus 5. Otherwise also you should take that value of lambda for which both the conditions are satisfied, and that value is only lambda equals minus 5, no other value. So 5 will be wrong, minus 5 will be the correct answer.
Excuse me, sir.
Yes.
Sir, what is the portion for the test which is being held on Sunday for the integrated students?
Okay. This Sunday only, no?
Yes, sir.
Topics will be same which were given to other students. I think sets will be there, right? Then linear inequalities and APGP. All right.
Okay, sir. Thank you.
Yes. Okay. Solve this question. Solve this question. So in the question they have given that x plus iota y is equal to a plus iota b upon a minus iota b. Okay. On the basis of that, you have to find the value of the expression x square plus y square. Try this question. Let me see what value you are getting. Can anyone tell me how to start this question? I mean, how you will find the value of x square plus y square?
So first rationalizing the denominator.
Yes, correct.
Simplify.
First, yes, good. First step should be the rationalization. See, whenever you are not able to understand how to proceed, just have a look at the right hand side and you have iota in the denominator. So at least try to rationalize it. Then you will come to know that what you are supposed to do after that. Rationalize it first, simplify as much as you can. So for that you will multiply numerator and denominator by a plus iota b. Now do the normal multiplication here. A into a is a square, then a iota b, then iota ba, and this is iota square b square. In the denominator it is a square minus iota b whole square. So this is x plus iota by, say, a square plus 2 I a iota b iota ba, one and the same thing, it is product. Okay, so we can write it as 2ab iota square is minus 1. This will become plus because iota square is minus 1. Now you write the terms such that real part and imaginary parts are separated, right? So from here you can write x as a square minus b square upon a square plus b square, and y as 2ab upon a square plus b square. We have these values of x and y, and we have to find the value of x square plus y square. Okay. Therefore, x square plus y square equals x square plus y square equals v square this, because we have value, and why we have written x as this and y as this, because what I told you, that if the two complex numbers are equal, then their real parts and imaginary parts will be equal, right? So in the left hand side, the real part is x. In the right hand side, the real part is a square minus b square upon a square plus b square. Similarly, the imaginary part is y, and here the imaginary part is 2ab upon a square plus b square. We have the values of x and y. They want us to find the value of x square plus y square. So we'll square and add them. Now simplification is left. Since it is a square, so both the terms will be squared, numerator and denominator. Here it will be 4a square b square. This is a square plus b square whole square. Finally, this will come out to be a square minus b square whole square plus 4a square b square. In the denominator it is a square plus b square whole square. And this thing will come out to be 1. You know why? Because here in the numerator we are using the identity. Identity has been used. Which identity? The identity used is x minus y whole square plus 4xy is x plus y whole square. This is the identity used from here to here. In place of a, here we have a square. In place of b we have, in place of y we have b square. And by using this identity, we have written this expression. Overall numerator and denominator will be same, so the answer will be 1. Important question. They have asked you to find the value. The value is 1. So what are these steps involved? First is rationalization. After rationalization and splitting, you will get value of x and y by equating the real part and imaginary part. Once you have the values of x and y, you square and add them because that is what is required in the question. Okay. Simplify that thing, you will get 1. Now here there is one important point that I would like to discuss. It is just a notation, not a point. I don't remember whether I have discussed it with you. In complex number, z equals a plus iota b. I told you that a is called real part. This I remember. I have discussed it with you. A is called real part of complex number or z. Important is this notation. Sometimes you will see this term like this: re bracket z. Re stands for real. Bracket means for part and Z is complex number. So R means what? Real part of Z. So what is real part of Z? Short form of writing this whole expression. Real part of Z is REZ. B is called imaginary part. B is called imaginary part of complex number. Imaginary part of complex number. And how we write it mathematically? B is IM. IMZ means we are taking first two alphabets from the term imaginary. So imaginary part of Z. So instead of writing this whole phrase, we use this thing IM bracket Z. Okay. So these notations are important. REZ means real part of Z. IMZ means imaginary part of Z. Because based on that, you will also find questions. Like for instance, if we are asked to prove this for any two complex numbers, and their names are Z1 and Z2, we have to prove that for any two complex numbers Z1 and Z2, prove that real part of Z1 into Z2 is equal to real part of Z1, real part of Z2 minus imaginary part of Z1 into imaginary part of Z2. Sometimes they use brackets, sometimes they don't. It is really fine because either I write REZ1 or I write RE bracket Z1. Meaning is clear, real part of Z1. See, I have taken this question from the miscellaneous exercise of complex number from NCRT. There's nothing like miscellaneous question or anything. Overall question is very simple. We just need to understand the terminology. What is RE, what is IM and everything. And they are saying that there may be any two complex number, not any two particular or specific complex number, any two complex number. Any two means general form. So let two complex numbers be, let us suppose Z1 as A plus iota B and Z2 as C plus iota D. Because when we'll be assuming complex numbers like this, only then we'll be able to see the real part and imaginary part, right? So they will not give A plus iota B and C plus iota D. They will just simply say Z1 and Z2. Now you will take the general complex numbers, and based on that, now you will prove this result. So as you can see, you have to prove that LHS is equal to RHS, right? See, RHS is very simple. RHS you can write it here directly. What you need to simplify is LHS. Like for example, what is REZ1? So you have supposed that Z1 is A plus iota B. So what is the real part of Z1? A. What is real part of Z2? C. Then minus. What is imaginary part of Z1? B. What is imaginary part of Z2? Small d. Right? This is your RHS. Now you need to solve LHS. What is LHS? LHS RE Z1 Z2. That means you have to find the real part of A plus iota B into C plus iota D. Only the real part, remember. Okay. So you keep writing real all the time, and finally you will write the real part. So for that you need to multiply this whole expression. This will come out to be AC, A iota D, iota B into C, iota square B into D. Write it for one more time, simplify it. This is iota A D plus BC and iota square is -1. Next step you will get the answer because you have to write the real part of this expression. You have to write the real part of this expression. Anyone can tell that the real part of this expression is AC minus BD. If instead of REIM was written here, then you would have written AD plus BC. Okay. So what you observe from here that LHS equal to RHS. So your result is verified. All right. You have simplified RHS. You have simplified LHS. Both are coming same. You have used the terms or the meanings of real Z and imaginary Z. Okay. Otherwise, it is based on simple multiplication value putting type question. Then after this, till now what we have covered? We have covered modulus and magnitude of complex number, and then conjugate of complex number. then something related to equality of complex number, and these two notations. Okay, after this we are going to study an important point, and that is argument, or let us simply start
So,
with this term principal argument. Yes, any doubt?
so that previous sum, can you just show the previous step before what you're showing right now? Just
I
the
think
previous
now it
step.
should be visible. Is it visible now?
Yes, so.
All right, done.
Yeah.
All right, now let us study the next point. Actually, this is the last topic of this chapter, and the topics covered in NCRT, but I will teach you something extra, some more things which may be asked in school exam. Okay, so that will be covering in tomorrow's class. But today, let us finish this topic. This is argument of complex number. Third important term. Tomorrow we are going to study the properties of these three terms. That means modulus, conjugate, argument. We will write down some properties, 4 5 properties related to every term,
Sir,
and we'll be solving questions on that. Yes.
sir,
Yes, what happened?
sir. Now you said you will teach something extra, right? Sir, that
Yes.
is there in the textbook.
See, it is not there in NCRT, but it may be there in some other school textbook. Like we
It
find
will
these
be
type of topics in some side books, maybe whatever refreshers or books you use, like RD Sharma, there is these topics are there. So, what type of questions do they ask in a school exam?
okay, sir.
Do they ask the question from NCRT, or do they ask the question from RD Sharma as well, or such type of books?
Mostly NCRT, but sometimes it comes from RD.
Yeah, sometimes no. So I won't be like taking all the topics, but yeah, some important ones. So that will be hardly based on one class only. All right. Tomorrow we'll be
Oh, okay,
completing
sir.
complex number, and next week we are going to study sets and straight lines. Okay. So our task is to
Okay, sir.
complete these topics in November. All right. All right.
Okay.
All right. So let's come to the topic. This is argument of complex number. Once again, something related to complex number, right? See, this is argument plane. Let us first understand the meaning of argument, then things will be easy for us. And this has something to relate to trigonometry, right? Some basic trigonometry will be used here. So, argument is basically the angle. What happens? You have some complex number a plus iota b, okay? And what does it represents? It represents a point in arcane plane. Okay, we have already discussed this thing. So, now what to do? We have this point in the arcane plane. Another point which has to be considered is origin. Now, what is argument? Listen very carefully. You have this complex number, you have the origin. Join both of them. Okay? Join both of them. And now consider the positive real axis. Positive real axis. Why I'm saying positive real axis? Because this is the positive direction, this is negative direction. Okay. So, what I have done till now, I have joined the complex number, which is actually a point in the Argand plane, to the origin. And now I am saying that consider the angle which this line segment OP makes with positive real axis. What is argument? What is argument? Angle which OP makes. Now what is OP? P is your complex number, O is origin. Okay. Which OP makes with positive real axis. This is your argument. You have to find this. I will tell you how to find it. Okay. I will tell you that also. Now actually what happens, based on the position of P, because P will not always be in first quadrant, right? P can be here also. P can be here also. So if you will join this to origin, then this will be your argument. Okay. If like P is here, and you join it to O, then this will be your argument. One more thing you can write angle in anti-clockwise. Angle in anti-clockwise sense. Okay. Angle in anti-clockwise sense which OP makes with positive real axis. Angle in anti-clockwise sense which OP makes with positive real axis. Alright. This is called argument. So based on the position of P, it can be in first quadrant, second, third or fourth. Argument which is theta, argument which is theta can vary from 0 to 2 pi because it can complete one round. You know why? Because P can be from in first quadrant or second or third or fourth. So depending on the position when you will join, either you will get an acute angle like this in the first diagram, or you may get an obtuse angle, angle greater than 90 degree, or you may get an angle greater than 180 but less than 270, or you may get an angle which is greater than 270 and less than 360, right? So that is why they say that argument can vary from 0 to 2 pi. From 2 pi and 0, one angle is excluded because you know why? When you are on positive real axis, suppose someone is on positive real axis, someone will say angle is 0, someone may say angle is 2 pi. So to avoid that confusion, 2 pi is taken in open interval. That means whenever the point is here, the angle which it makes with positive real axis will be taken as 0 and not 2 pi. Okay. The interval is 0 close to 2 pi open. We will also see how to find these arguments. Okay, don't worry. Just try to understand the basic meaning of argument first. Okay. What is the meaning of argument and what is the interval of argument? Then we will see how to find the argument. Okay. Because mathematically we will not be asked to make it measure the angle graphically or geometrically. We will be given a complex number and we will be asked its argument. So we have to see how we'll find it. Okay. So we'll wait for that. First, we have understood what is argument. Then there is another term, and you'll be using this only. You will be using this only. In the question, you will be asked principal argument and not argument. Okay. Very, very important. Okay. In the school exam, or otherwise also whenever they ask you about the argument, they want you to find the principal argument. Okay, how to find the principal argument, this I'm going to tell you, and this is going to be used in finding the argument and later on a term called polar form of complex number, but let's not get into it. First let us understand what is principal argument. So the angle which OP makes, now you know what is OP, which OP makes, okay, with positive real axis, positive real axis. Let me give name to this angle, the angle theta. The angle theta which OP makes with positive real axis such that, now here also this interval is extremely important, okay, such that minus pi to pi. Pi is on open, minus pi is in close interval. Till now you were studying argument. What is the interval of argument? 0 close to 2 pi. But now they have introduced one more term, principal argument. So what they are saying about principal argument? They are saying that it is the angle theta which OP makes with positive real axis such that what is its interval? Minus pi close to pi. Now definitely it is a natural question, sir, how we are supposed to find it? If we cannot measure it graphically, then what is that mathematical approach or algorithm by which we have to find the principal argument? I am going to tell you few simple steps. Just follow them and you will get the answer directly. Working rule. Working rule to find principal argument. And then I will tell you everything. I will explain it geometrically also. So then you will understand what is argument, what is conjugate, what is modulus. You will see everything in the same diagram. Working rule to find principal argument. First thing, write write complex number, write complex number z in the form, in the standard form or in the general form. Okay. The first thing that you have to do is write complex number in standard form. That is, you should always express the given complex number in the form a plus iota b. Second, from here, find acute angle alpha. Find acute angle alpha using a relation that tan alpha is mod b by a. Okay, from here you will find the acute angle. We will solve these steps. We'll use these steps in the question. Then principal argument is third and final step. Principal argument is first alpha if z is in first quadrant. Z is in first quadrant. Pi minus alpha if z is in second quadrant. Minus pi plus alpha if z is in third quadrant. And fourth, minus alpha if z is in fourth quadrant. So only three steps. First, you need to write the complex number in the standard form. Then you will use some formula that tan alpha is mod b by a. From here you will find the acute angle alpha. Then you will use this table, and on the basis of this table you will be able to write the principal argument depending on the position of the complex number. To understand all this thing and later on understanding this thing graphically, let us quickly take an example. Find the principal argument of complex number z equals 1 plus iota. Okay, this is the question. Let us match all these steps. First thing, z is 1 plus iota. Is it written in the standard form? Answer is yes. Okay, now let us come to the second step. From here we will find some value called tan alpha. And what is tan alpha? It is mod b by a. What are a and b here? Because we are comparing it with the general form a plus iota b. So definitely a and b both are 1 1. What I told you, from here you will always find the acute angle. That angle is pi by 4. Tan alpha 1, acute angle 45 degree, everybody knows. Pi by 4 radian. Last point, principal argument. From the third step, you observe the first point and that is your answer. Principal argument is pi by 4. You know what is the reason? Because z, which is 1 plus iota, which is actually a point, in Argand plane, is in first quadrant. Okay, so this is the meaning of principal argument. Now let me tell you each and everything graphically or geometrically. Please understand. This is your Argand plane, right? This is your real axis. This is your real axis. This is your imaginary axis. Okay, real axis, imaginary axis. You have this complex number 1 plus iota located geometrically. So it will be somewhere in the first quadrant. You know how to write 0, 1, 1, then 2 and 3, etc. Not required here, right? So your point is minus, sorry, 1 comma 1. This is your point P. Now, you know what you have calculated. What is this principal argument pi by 4? You know what is the meaning of this? When you join P to origin, then the angle which this OP makes with positive real axis is pi by 4. You have calculated this. And always remember, principal argument is between minus pi to pi. So you will always get this answer minus pi to pi when you will follow this working principle. Also, in the same question, if someone asks you what is modulus of z, which means this length OP, which means mod z, which means under root a square plus b square, then here in this particular question, your answer will be root 2. So now you should understand what is OP. OP is your magnitude of mod z, which is root 2. And what is this angle pi by 4? It is the angle which this point joining origin makes with positive x-axis. What this angle is called? Principal argument. What this length is called? Modulus. Okay. Angle is in first quadrant. Now, to understand this principal argument, let us take one another example where the point is not in first quadrant, right? Let us take one more example. Find the Principal argument. Find the principal argument of the complex number. Find the principal argument of the complex number z equals minus root 3 minus iota. This is the complex number minus root 3 minus iota. We have to find its principal argument. Okay. Just wait for a minute. All right. So this is some different complex number. We have to find the principal argument. Listen once again. All these steps now you should remember. First thing is to write the complex number in the standard form. It is already written. First thing. Then the second thing is we find tan alpha from here. There is this some quantity tan alpha. Just remember. And what is this quantity mod b by a? See, always compare it with this form because you need the values of a and b. And the formula is tan alpha is mod b by a. So this means tan alpha is mod of, in place of b we have minus 1, in place of a 3. This will become 1 by root 3. From here we have to find the acute angle. Who will tell me what is the acute angle that satisfy this equation tan alpha 1 by root 3? Tell me what is angle alpha. Yes, hurry up. Tan alpha 1 by root 3. What is alpha? Why you are taking so much time?
Pi by 6.
Pi by 6, that is 30 degree or pi by 6 radian. Now this complex number z, which actually represents a point, is in which quadrant? Is in third quadrant, right? Because both of them are negative, real and imaginary part are negative, x negative, y negative, like that. Third quadrant. For third quadrant, we just need to remember that table. Principal argument in third quadrant will be equal to, let us see. See this, third quadrant, third point. In third point, sub point third, principal argument is minus pi plus alpha. Minus pi plus alpha, where z is in third quadrant. So what will be your principal argument? Principal argument will be minus pi plus alpha. And the answer will be minus pi by 6, which is minus 150 degrees. Alright. Now let me tell you how to understand this graphically. Where is your point? Your point is in third quadrant. Minus root 3 minus 1, right? This is real axis. This is imaginary axis, okay? And this is your Argand plane. Argand plane. Point is in third quadrant. Minus root 3 minus 1. This is your point P. This is point O. Listen carefully. Last thing. When you join O to P, okay? Principal argument is coming minus 150 degree. And this is your real axis from where we measure the angle. Can anyone tell me that this angle minus 150 degree, which type of angle is this? What is the direction? Can you tell me?
Clockwise.
Yes, this is clockwise, right? Minus 150 degree. So this is the angle which OP makes with positive real axis in clockwise sense. This is your point minus root 3 minus 1. If someone asks you what is this distance, this will come out to be 2 because OP is your distance which is mod z, and mod z is calculated as under root of a square plus b square. So if someone asks you, this distance will be 2. Now you know what is the basic difference between argument and principal argument. See, in argument, no one asks argument actually. I tell you this. In argument, see what is the interval of the angle 0 to 2 pi. And also I have drawn all the four graphs which clearly show that I am measuring angle always in anti-clockwise sense in simple argument. But in principal argument, if you look at the interval which is minus pi to pi, so it is clear that some time angle is measured in, not sometime, some parts. In some parts, angle is measured in anti-clockwise sense, and in some parts angle is measured in clockwise sense. To understand this, I will tell you, whenever you will get angle in the first quadrant and second quadrant, I'm telling you this, you can verify yourself. Whenever you will see that Z is in first or second quadrant, your angle will come positive. And whenever your point will be in third or fourth quadrant, you will get a negative angle. So that means when point is in first and second quadrant, you know which part of this interval will be coming, this interval 0 to pi. And whenever your angle will be your point will be in third or fourth quadrant, at that time your angle will be coming from minus pi to 0. So minus pi to 0 clockwise, 0 to pi anti-clockwise. Actually, principal argument is defined as such. There is no such question like why, how. No. It is just defined as such. 0 to pi, first, second quadrant, minus pi to 0, third, fourth quadrant. Third, fourth quadrant negative, first, second positive. You need not to learn anything like this. Just follow this table. You will get the answer by yourself. Okay. So here I was explaining this thing that why we are getting minus 5 pi by 6 because of this table. And what is the meaning? That this PO is making 150-degree in the clockwise sense with positive real axis. Someone asks you about the mod z. That means distance of P from origin. Use the formula under root A square plus B square. If in the same question, see, if in the same question, someone asks you about the conjugate. Today we have discussed three important terms. One is modulus, then conjugate, and third one is argument. So if someone asks you about the conjugate, now you can write the conjugate as well. This is minus root 3 plus iota over. This is it. So this is everything. This is everything which is related to complex number in NCRT. A little bit portion is also left. Little bit portion which is called polar form of complex number. Polar form of complex number. This is your next heading. Just remind me in tomorrow's class. Okay. If I forget, just remind me that I have to teach this polar form of complex number. Okay. So it will hardly take 5 to 10 minutes. Then after this, what we are going to do? We are going to study something extra, which may be asked in your school exam, like properties of conjugate, modulus, and argument. Okay. Tomorrow we'll be finishing this chapter. Next week we'll be studying about sets and straight lines. Okay. So these are the topics which are going to come in your coming school exams. Okay. We have to complete that first. So if there is no doubt, that's it for today. Thank you very much. See you tomorrow. Bye everyone. Take care.
Thank you, sir.